I think hopefully from our side we hope to have good time with all of you, and our topic is today introducing the Docling project that we've been working since quite a while, not that long, as you will see in a moment, but we're looking forward to share what we're doing. I'm here, my name is Michele, I'm here with my colleague Cesar that will also take some of the of what we're going to show you today, including live demos if we manage to. Just to put a bit the stage, we actually have the talk today on so basically this one on Docling, and we will also have the chance tomorrow to have a longer workshops where if you really want, you can really go hands-on. So we're also invite everybody to join tomorrow to go a bit deeper into really building also your own use case, or to really to build something together with Docling. And actually also to get a bit of a feeling here, let's maybe see if everybody's already awake after lunch, and let's start with a small, the usual surveys poll. So developers, how many developers do we have here? Perfect, that's a perfect audience. AI developers, AI engineers, good. And how many of you actually are working with documents as data? And how many of you know about Docling already? This number is increasing. I mean, we ask it every time, and it's initially was one shiny hand, and now actually we cover I think what, a quarter of the room. Okay, so we will anyway do also go basic, such that everybody can get up to speed with Docling, and maybe next time we're going to see even more hands. Docling is a project that we created in our team. And that's also why we are here. It's a nice open source package, really focused on converting and processing documents. So basically, our goal is to have a tool, specifically something you can even call a library, an SDK that takes PDF, Word document, Excel, CSV, I don't know, I think the list is getting longer and longer as an input format. And it's actually trying to extract what we really like to call the content. So we really try not to focus too much about how the document looks like, but what it contains, and to extract in a way that you can trust what you get out of it. You will see in a few examples also how in general sometimes you cannot really trust what comes out of simple PDF readers, let's put it this way. We're also expanding Docling with more and more capabilities, and I mean, one of the key things that we love to embrace is the full concept of multimodality. So we love to really be able to tackle documents and everything that documents contains, from charts understanding, tables, and all of the other complex components. So this is a bit the what. Let's maybe move next to who is behind Docling.
So yeah, better an image. So we are a team of 15 people from different countries, and we're located in Zurich, Switzerland. But we're actually more than the people you see here in this picture. We are an open community. We have almost 2,000 active contributors, according to the latest metrics from the Linux Foundation. And actually, the community response has been amazing. Docling is already a reference in the document understanding space. And all started in November, last November. That was the breaking point when Docling went viral, and we got 12,000 stars in 1 month and became #1 trending package in GitHub. Now we have more than 37,000 stars. And since then, we're flooded with feedbacks, code submissions for new features and collaboration projects with the open source community. And of course, how can we strengthen this community? Making it developer friendly also means having a seamless integration into popular data science and AI frameworks. And we provide native integrations with LlamaIndex, LangChain, Haystack, and many others. Also, Red Hat ships it as an official maintained package in RHEL AI. And many other examples. Maybe you heard about the PDF to podcast project from NVIDIA. So they were using Docling as a document processor. And yeah, we are working full steam in Zurich and beyond to guide people with their integrations. So you can find plenty of code snippets and notebooks in the Docling documentation.
Good. One point, Cesar, that we forgot to mention actually already before, is that actually since April, Docling joined actually the Linux Foundation for AI and Data, that is also like hosting here today. And this is like, was actually, I would say also like a big change for us, because it really like put us into the position of wanting to really promote more the open governance of the project and really like making the community even bigger. So we are like here actually thanks to the community, thanks to the people that here are already using Docling, and we want to even grow even more. So if you didn't put the star yet, go and put the GitHub star. We're going to repeat it, I don't know how many times today. But maybe before you jump straight, you want to understand what the heck is Docling doing. So here we have like a small recording of how you can actually convert documents with Docling. That's a usual complex documents. You see multiple columns, tables with multiple column headers. You have seen figures in the document with captions connected to it. So with Docling, in this case, we just invoke it quickly via the CLI. There is a full Python SDK behind that can be used as well. And you see the converted documents, and actually all of the artifacts in this case are like the images that are embedded into the document popping up. You see how the results looks like in some sort of HTML export, where you see the sections, the headers are recognized, the figures with their captions, everything is linked together, and complex tables like this one, where you have like multi-column headers, really like get out correctly. That's really like it's one of the key features that we like to emphasize of Docling. Something that we also like from time to time to talk about is how it can go bad if you don't use Docling. So I don't know if you were like, this is like something that was around the social media, I think by now like was beginning of the year. So in a nutshell, what you see is what happens when models are being trained with bad data. And bad data can originate from bad PDF parsing. In the specific, there was a paper in 1959 that is like, again, one of these classic scientific documents you see basically here, as I mentioned, to move the mouse, with like 2 columns, and it has the word vegetative and electron microscopy on 2 different columns. They have nothing to do with each other. But let's say, trivial PDF parsings made a single line of text out of it, which was used to train LLMs and the models that people use now to write scientific papers. So when people were saying like, oh, I need to put a reference to this famous paper of 1959, the LLM suggested that this is a nice paper about vegetative electron microscopy, which is a nonsense. It does not exist at all. And it's going on because now people, I mean, it went to peer reviewed. There are like multiple instances of this. And that's really just one that was found. There are like many other cases like this one. As an example, we can actually show that the same document with Docling, it's showing the correct paragraph. Maybe I need to turn this one. Where vegetative and electron microscopy are completely at the opposite ends of the paragraph. So that's basically like also highlights what we really try to take care with the Docling conversion pipeline that you're going to see in a moment. Key features are, for example, the fact of identifying all of the regions in the document, on the page of the document, with their semantic meaning. For example, understanding that something is a page header, understanding that something is a table region, or it's a caption connected to a figures. Or that actually a paragraph, like you see like down here, it's connected to the one on the next column, or to the next page, for example. This is all of the key things that we want to, that we address with Docling to really give back, as I was saying in the beginning, the content. Really like what is the content of the documents that you have. Another reason why you need to really think about if you're using the right tools in your document processing pipeline is trust. So you might be familiar with this type of topics, SQL injections, spoofer, like you can just find tons of those. I mean, I think most of them have to go through cybersecurity educations, right? I don't know if you heard about these cases now. That's like a simple Google search by searching for specific keywords that highlights some papers that people, I hope not you, some people actually submitted for journals, where if you read the papers, looks legit, it's like an interesting paper, but then there is like this weird white region there that if you actually select with your cursor, you would actually see that the content, it's not just empty. So basically, like, people now start to put prompt instructions. So in case their paper is being reviewed by a lazy reviewer, that's another problem, the LLM will actually overwrite all of its previous instructions and provide only and only positive feedbacks on the paper. Anyway, these are like really like some of the key elements that we really like to emphasize, and we really try to address most of those with the conversion pipeline that we have in Docling. So how does it look like? In Docling, we have this concept about pipelines that are really like specific to what the document contains and what are the characteristics. We can start from the simple pipeline, the basic one on the bottom. That's really like what usually we use automatically. You don't have to specify anything when you don't need to do any sort of AI processing. So in this case, you can take programmatic documents like a Word document, PowerPoint, Excel, and a few other ones. And we try to parse it and to create what we call the DoclingDocument, like the format that Docling is creating as an output. Just above, it's basically what we had since the beginning in Docling, which is the standard PDF pipeline, which is, yes, it is using a PDF reader, exactly like the case of the vegetative electron microscopy before. But then it applies a sequence of steps that really allow to fix all of these, all of the linking and all of the, really like the, all of the topics I discussed before. And this in the specific going to like analyzing the layout of the page of the documents and being able to reconstruct the table structures and eventually build up again the DoclingDocument. Once we have the DoclingDocument, we can really focus not only on the parsing, but also on trying to understand what it contains and to make it really, as we use in the headline, ready for your next Gen AI applications. One of the things we actually can do is what we call enrichments. Enrichments is a step in the pipeline that allows to analyze further some document component. The one that we usually show are like pictures, figures that you have in the document. In this case, we can enable what we call we can enable two steps. One which is called the picture classifications, which is really like a very, very tiny model. We're talking about something like 8 megabytes of models, which is trained specifically to understand what type of figures and pictures you have in the document, like, but really specific. I mean, we don't care about saying like that's a clicker. We want to understand that's a pie chart, that's a logo, a signature, or this kind of components. And the second part is what we call picture description, which allows to, inside the pipeline, to interact with a nice vision language models that can really contextualize, write a textual description of the picture. And it does so basically with the prompt that you specify. This is basically like one of the key things you can do if you want to build a multi-modal reg applications, like actually the one we want to show you tomorrow in the workshop. How are we? So there is like one, I will actually go quickly to another quick topic that we have been working on, and we are pretty also proud of the results. I was skipping, maybe on purpose, the box on top in these pipelines, which is what we call now the VLM pipeline. So a pipeline that allows in one shot to do all what the previous models were doing before in a sequence. And this is a pipeline which is powered by a model that we developed in our team. We call it SmolDocling. As the Docling package was going viral and was trending on GitHub, SmolDocling was trending on Hugging Face. It was actually the #1 model across all of the models. So we loved when we took these screenshots one day where actually you have all of the DeepSeek, Mistral, Llama, they're all like below us. At some point you have to take screenshots when this happens because you cannot roll back. What SmolDocling is a very, very tiny model. We're talking about not billions. We're talking only about 256 millions of parameters. But it is a model that can do everything that we usually do in all of the dedicated steps in the Docling pipeline. So the fact about doing layout segmentations with exactly the bounding box around where each component is, reconstructing the table structure, describing figures, classifying pictures. These are like all features that SmolDocling is doing in one shot. It's a model that we're developing further, so the current release is only in preview, but soon we're going to have like more releases. One interesting stuff is that, as I mentioned, it's a very small model. As you can imagine, when you think about small models, you think about being able to run them on small devices. So actually, SmolDocling can run on a phone. And that's why now we are, for example, looking into generating new synthetic data of fake real documents in the real world that will help us to actually make SmolDocling also work really like on real world images. So that was lots of talking on how Docling works. I think there are like more exciting topics next.
Well, actually, what is next with Docling? Just guess it. Of course, Agentic AI. And as Mark said this morning in his keynote session, agent is a third pillar of open source AI. And yeah, Agentic AI is a powerful framework because it's about accomplishing goals with limited supervision, so through agents. These agents can reason with LLMs and interface with tools. So that's what we are providing now, these agentic tools. Mark also said something important about cooperation and standards in Agentic AI, and maybe the MCP protocol is the one that is getting most awareness. So we created Docling MCP. And yeah, it provides several tools that enable or that let you run the capabilities of Docling, like conversion, generation, manipulation of documents, and again, the integration. So we have several integration examples with frameworks, for instance, with LlamaStack and Pedantic AI. We provide examples for information extraction. And we will see several examples like this tomorrow at the workshop. But maybe it's better to show a couple of examples with actually LM Studio as a MCP host. Here we are. Okay, so this is just showing the interface of LM Studio and the MCP Docling server with the different tools that are available. And just to go fast, I mean, we can type, convert this document that is on this URL and give me a brief summary. So then it will proceed with a conversion tool, and then the export to Markdown to have the summary. And of course is the paper about Docling. And yeah, I mean, we have several ones, like if we say, show me the thumbnail of page 3, and then it will use one of these tools to actually create a thumbnail on one of the pages of the document. Now, we can also say, okay, let's create a new one. For instance, create a document on the future of open source AI, add a paragraph, create a list, add some topics, some different elements of the document. And this, what it's going to do, it's actually, it will create a new Docling document, as Michele described. This is our unified structure of the documents. And then it will proceed creating different content that follows the structure of the Docling document. And, OK. And finally, I see some things. Closes the list, and it exports to Markdown, and we get a sample document. But we will see more examples tomorrow at the workshop here.
Good. So we don't have to write papers anymore. Like, we can use tools. They're going to be nicely formatted. We get the Docling document. That's great. I actually wanted to show you like another integration collaborations we have. It's actually with our colleagues at Langflow. I don't know if you're familiar with it, but actually if you really want to jump and use Docling in your data pipeline, basically without any piece of code, this is Langflow. It's a very nice tool that is doing like the so-called low-code, no-code pipelines. And we recently just integrated, as you see here on the left, we have actually the, somewhere we have the Docling bundle here, where we have a few components that can really like help to use Docling inside the pipeline. For example, we can provide documents for converting, either using the library internally or using a Docling serve, which is a REST API, which is wrapping the Docling interface. And then what we actually have here, it's a few examples of different ways in which you can interact with the output of Docling, of the converted document. You can just say, OK, export it to Markdown, and then I will use my standard tools, for example, split it, chunk it, and then ingest it into a VectorDB. I think in this conference today, everybody's going to be opinionated on open source, so that's why we put open source there. The other possibility is to chunk directly a Docling document. That's actually a very interesting capability, because you can, we actually have chunkers that are really specialized in the splitting the document according to really like to the components that the document contains. So not only like strings of text, but really knowing like if something is a header with a proper table structure, to have like list, sub-list, all of that one properly represented. So it's like, it's not much to show, like in the sense like it is there, it is just, you can just click around and it looks nice, but it is really powerful, and you can really do great applications with it. Going back to our deck, where are we? To the end, right? This one we showed. So another interesting part is like this component, this style I was showing before, Docling serve. It's actually a REST application that we also have part of the Docling ecosystem. And one of the things we're doing in collaboration with the colleagues in Red Hat is actually making it available as an OpenShift operator that can really be deployed only with one click on your OpenShift cluster.
Good. So we are almost finished. Just to wrap it up, what is Docling? Docling is an open source library that converts documents from several formats, PDF, Word, Excel, HTML, into a unified structure, the Docling document. And from there, it enables multiple AI applications, integrations with your preferred framework, and several enrichment applications like we've seen before. And yeah, just try it out, install it, run it, put a star, and you can also read our technical document if you need more technical details. And of course, I invite you all to join our workshop tomorrow at 2:10 here in this same room. And thank you very much for attending.
Yes, I think I don't know what is the schedule next, but we can take a few questions. I think on the back there, yes?
Thank you very much for this really interesting presentation. I'm really curious to know how Docling is dealing with vectoring signature and writing signature.
So the good story is that we were surprised ourselves to see how good is SmolDocling good in understanding handwriting text. So actually, you can actually get quite somehow to fit if you use the SmolDocling and these VLM pipelines. The standard PDF pipeline does not have anything particular to recognize handwriting or other components. It will rely on the OCR engine you put in between. But now with the new VLM pipelines, this is coming almost out of the box. And it's going to be like in the new models we're going to release, we're going to also put a bit more emphasis into that one as using it as training data such that it can be used. There in front.
I'm sure we will see that tomorrow, but the SmolDocling model is enabled by default, or will do something to
SmolDocling, it's not the default behavior is the standard PDF pipeline. The default output is the DoclingDocument that then can go to Markdown, to HTML, or into any other application. SmolDocling is part of the VLM pipeline that you can just enable. For example, in the CLI, if you put -- VLM pipeline equals VLM, it's going to use SmolDocling.
It's an option.
Yes.
Thanks for the great talk, Michele. It's awesome package. And so there is Docling layout, and you want it to become a standard. Can you talk a little bit? What do you envision the standard to be used for? Like, who should be working on the standard? Who should be community around the standard?
So you touch on a topic, maybe we didn't mention it too loud before. The DoclingDocument, or especially like what we call the DocTags representation of the DoclingDocument, it's the format we need in SmolDocling in the specific to be able to capture all of these extra features that are useful during the conversion process. For example, DocTags are like specific tokens that we put into the LLMs to specify the location of where each piece of text is located, to have the proper table structure coming out, even with a proper multi-column headers and so on and so forth. We are actually looking forward to make it a bit of like a standard that can be consumed, such that people can train model on it, that actually more libraries can consume it directly, because we really believe it can really make the content of the document friendly to an LLM, to be able to really interact with this. So that's a bit like the target we have. And we are more than open to actually collaborate on defining these new standards. We have a draft, which is basically the doctags format that we use as an output and as an input into Docling. That is already something that people can already have a look. And I think we're going to have soon some open thread conversation also on really what type of maybe of features maybe it's missing or maybe should be do differently. So that's going to be a community-driven effort for sure. And you mentioned community. I don't know if I was supposed to advertise it that much, but we are going to soon also launch some more community Discord channels or so. So it's all coming soon.
Can we have 1 minute?
One.
About unwritten documents, we've tried a little while ago with the layout, the detection, and the text detection with unwritten notes, which is exactly good enough.
You mean notes on top of documents?
Notes on top of the documents or unwritten documents, in both cases.
Well, I would decouple the two, honestly speaking, because usually like handwritten documents or documents with handwritten parts, those I think should be treated as documents eventually, where you want the content to be fully there. When you say like notes and annotations, maybe actually in the DoclingDocument we have a concept of content layers, which is actually coming from the idea of imagine you process PowerPoint slides through Docling. You have these like presenter notes. Those actually go in the DoclingDocument, but in a specific content layer, which is not visible when you do export because it's not the real content. It's just an auxiliary content. So actually, like handwriting notes can actually go into that auxiliary layer. But back to your question, I think it's also a bit what the other colleague was asking before. We have support. I mean, SmolDocling is getting better and better in recognizing handwriting and to do something with it. The standard PDF pipeline would really rely on the OCR engine you put on the back. And actually, on that part, Docling is pretty modular. You can there is actually plug-in mechanism where you can put whatever OCR engine you want in the step of the pipeline. Yeah. So if you have one that works very good in handwriting, you can actually put it there. And that's just one step that then will be creating what it's used in all of the next stages of the pipeline. So it's really just a swap and replace in one of the components. Okay, thanks a lot. Thanks for the question as well.